Okay, guys, so let's look at some question for like a review for the final. The first one, of the following examples are chemical change, except. So a chemical change will happen if you have a change in the substance, right? So here, the first one, the formation of wine. Fermentation of wine is a reaction. It's happening here. The fermentation is also a reaction. The tarnishing of silver. So you see the change in color, right? So changing color is also one of the observations that we have when a reaction is happening. So the answer here would be condensation of steam, right? Because what's condensation? We're then changing from vapor to liquid, right? It's like you have the water vapor, the H2O vapor, to the H2O liquid. C is still H2O, so the substance is not changing. So the answer should be condensation, letter C. Letter D is the combustion of butane gas. So here is the combustion. So remember, combustion, you have here a compound with carbon, burn with oxygen, producing CO2 and water. So a combustion like this, a complete combustion, will also produce carbon dioxide and water. And then the rusting of iron is also a reaction, right? You have an oxidation of iron here. Question 2, homogeneous mixture are also known as. So which one is the answer here? So you have heterogeneous mixture, right? That's when we see different things. For example, here, if you have sand and water, you can see the difference between what is sand and what's water, right? So it's the heterogeneous. Homogeneous is when you think just one thing through, a uniform. For example, sodium chloride in water. You see just one thing, right? A uniform appearance. And another homogeneous mixture can also be also known as solutions. Right, then how many significant figures are there in measurement? 0.0 to 2357. So remember, the zeros before the significant numbers are not significant here. That means this one has 4 significant figures, 1, 2, 3, 4. Right? For example, if the question was, how many significant figures you have here? 2.00, the answer is 3. Because the zeros after the decimal point here, they are significant. But before the numbers, they are not significant. Okay? Right. So number 4 here. A certain liquid has a density of 2.63 grams per cubic centimeter. So then you have here 30.5 milliliters of this liquid will have a mass of, right? So you are going to convert here from grams to kilograms. But first, let's find how many grams you have here. So density is equal mass over volume, right? Or also can use the triangle here to help. Density, right, is mass over volume. So if you look here, so you can be able to find all formulas. So density is mass divided by volume. Okay. Mass is density times volume. And volume is mass divided by density. So you have all 3 equations. You can use this triangle to get all 3 equations, right? Density is mass over volume. Volume is mass over density, and mass is density times volume. So That means here, the question is asked for the mass, so let's use the mass is equal density times volume, right? So, okay, mass is equal, what's the density here? 2.67 grams to cubic centimeter, right? Times the 30.5 is the volume given. 0.5 milliliters. So we're gonna have the answer here. In grams, so we cancel. Oh, cubic centimeter is equal to 1 milliliter. So here. So yeah, that's the one, we can cancel out here. You know the final answer will be in grams. So multiply 2.67 grams times 30.5 to have your answer grams. After you have your answer in grams, you need to convert to kilogram because the question is asking in kilograms, right? So please do your calculation there. First multiply 2.67 times 30.5 to have your answer in grams. Then you know that you have your answer in grams, right? So you know that each one, look at the relation here. Each 1 kilogram is equal to 1,000 grams. So cancel here. Grams cancel with grams, so your unit here will be kilograms. So after convert to grams, just divide by 1,000 to convert from grams to kilograms. And then select your answer here. All right. Now, question 5. The density of 167.4 grams of magnesium have a volume of 960.32 milliliter is, and we need to answer in grams per cubic centimeter. So you already know that each 1 milliliter, right, is the same as 1 cubic centimeter. So you can write it here. Density is mass divided by volume. So density is 167.4 divided by 96.32 cubic centimeter. Okay, so you cannot see this result. And then, sorry, grams. Then do your calculations here. The unit will be in grams per cubic centimeter. Right. Question 6. An atom of the most common isotope of gold. So the mass weight here, right, is 197. Has how many protons, neutrons, and electrons? Okay, let's look periodic table here. So gold here, right, 197. So, sorry, the atomic number is 79. So if the atomic number is 79, something means that we have 79 protons. And this atom here is an atom, that means there is no charge. So if it is an ion, would change, right? But this here is not an ion. We are not seeing any charge in here. That means for this situation here, the number of protons is equal to the same number of electrons. So we have 79 protons, 79 electrons. And how to calculate neutrons? So to calculate neutrons, you are going to subtract here the mass, 197, subtract here 79, right? So please do the subtraction here to find the neutrons number. Okay, so proton 79, electron 79, and then calculate the subtraction here to calculate the neutron by doing a subtraction. Okay. Okay. So question 7. How many significant figures are there in the measurement? So remember, all the numbers before, all the zeros before the significant figures, they are, sorry, the zeros here, they are not significant, right? But all the zeros after decimal place here, you can count. So have it 1, 2, 3, 4, 5 significant figures. So the answer is B. Okay, number 8. How many electrons, protons, and neutrons are in chloride ion? Formed from chlorine 35. So chloride ion. I've seen here that you see I have a minus here. What does the minus sign mean here? That you have what? Extra electron, right? So that means this chlorine here, we have one electron. That means it's going to be chloride. Okay, so chlorine 35, right? The atomic number is 17. If the atomic number is 17, that means we have 17 protons. Right? But you have the minus here, that means you have one extra electron. So initially, I was 17 electrons, but because we have the minus here, because it's ion, now we have 18 electrons, right? And then to find the numbers of neutrons, we are going to do the same thing. We are going to subtract the number of 35 minus the proton number. So gonna be 35. Oops, no here. Oh, yeah, whatever it is. 35 minus 17. And then we're gonna do subtraction here. Okay, so what you know here? The numbers of protons and neutrons will not change. So even you have just the chlorine atom and the chloride ion, the numbers of protons and neutrons are the same. But if you have electrons, sorry, but if you have ion, if it is negative, you have extra electrons, right? And if you have negative, the cation have, so it's gonna be lost electrons here. But in case here, -1 means one extra electron. So calculate the answer here. Okay. So what's the abbreviated electron configuration for nickel, right? Atomic number is 28. So we are going to calculate it, to find here. So everything this helium, argon, krypton here, you're going to find what's the atomic number for these noble gases here. So helium, atomic number 2, neon 10, argon 18, krypton 36. So you already know that the answer is not this one, because it has more than 28. 36, right? Krypton is 36. And then helium is 2 plus 2, 4 plus 3, 7. So the answer is also not helium here. So argon is what here? 18. So okay, you may choose this, this or this. What's gonna be the answer? You needed the one that it matches 28 atomic numbers. So which one matches 28 atomic number? 28 electrons here. So 18 plus 2, 10. Oh, sorry, 18 plus 2, 20. 20 plus 8, 28. So the answer should be B. So the shape of ammonia molecule is, so let's first count the numbers of valence electrons. Nitrogen, right here, group 15, 5A, right? So we have 5 valence electrons plus each hydrogen, each hydrogen has 1, right? So we have 3 hydrogen here, so 3 times 1. So how many valence electrons we have in this molecule? 5 plus 3, 80 valence electrons. Okay, now let's first write here the symbols. Nitrogen with 3 hydrogens, 1, 2, 3. Now let's connect it, right, drawing the, making the bond here. And each line here is 1 bond, and each bond counts what? Each bond here counts 2 electrons. Okay, 2 electrons, 2 plus 4, 2 plus 2, 4 plus 2, 6, right? 6 electrons, so 8 valence electrons minus 6. So you still need to write, to draw here 2 valence electrons. Where we're going to draw these 2 dots. So hydrogen, we do not need to add anything because hydrogen it's okay with only 2 electrons. So you don't going to add any dot here for hydrogen because it already have with 2 electrons. So, okay, now let's work with all this hydrogen here. They are stable. They don't need any dots anymore. But nitrogen, how many electrons we have right now? This nitrogen here. 1, 2, 3, 4, 5, 6, 7, 8. So let's draw these 2 dots here. 8. This is how they're supposed to be this molecule here. And what's the molecular geometry? You have 3 bonded domains and 1 non-bonded domain. You have the trigonal pyramidal. Okay. And what's the hybridization for NH3? So how do you count hybridization? You count the bonded domains, like 1, 2, 3, plus the non-bonded domains, 4. So we have 1, 2, 3, 4. Which hybridization is we have for 4? sp3. So the answer here will be sp3, right? Just a review here, talking about it. If you find the three domains, the hybridization will be sp2, 1 plus 2, 3. If you find 2 domains, will be sp, 1 plus 1, 2, right? And for sp3. Now, what's the molarity of a solution What's the molarity of a solution that contains 17 grams of ammonia in 0.50 liters of solution? Okay, so molarity. What's the molarity? Molarity is moles over volume of the solution in liters, right? So let's take here Let's first find the mole numbers, right? Mole number is equal to what? Mole number is the mass divided by molar mass. Okay, so the mass given here is 17 grams divided by the molar mass. What's the molar mass for NH3? Let's go here, right? Nitrogen is 14. Okay, nitrogen is 14, right? 14 grams per mole. And each hydrogen is 1 here. So each hydrogen is 1. But you have 3 hydrogens, right? So times 3. So the total here will have 17 grams per mole. Grams per mole. Okay, so you can see here that if the mole number is, we have 1, right? 1 mole here. So now just divide it. 1 mole by the volume given here. The volume is already in liters, so you are okay. But if the question was, if it was given milliliters, you had to convert to liters, right? Okay. Right, so this one, how many calories are required to raise the temperature of a 35 grams sample of iron from 25 to 35 degrees Celsius? So then the specific heat, the iron specific heat is 0.08 calories per gram degrees Celsius. So let's calculate which form we calculate the heat here. So Q is equal to MCAT. MCAT here, right? Mass times specific heat times delta T. So M is 35, right? Times C specific heat here was given. Calorie per gram degrees Celsius. And then delta T is the final minus initial, right? 35 minus 25, that's going to be times 10 degrees Celsius. Let's cancel out the unity here. Gram cancel out with gram here. Cells with cells, so you know that your unit will be in calories. So please multiply 35 times 0.108 times 10, right? To have your answer here. Okay, so now you have here the name of Al2 SO4 3. So you have here a metal with this ion here, right? This aluminum here is not a transition metal. So if it's not a transition metal, we do not need to say the charge here. So aluminum is just an metal. It is not a transition metal. So you are not, this is not the answer here, right? So this here, it's not a it's not a covalent molecule. So you are not going to use di. You only use di if it is like a molecule, right? If it's like, if you had covalent bonds here. In that case, the answer will be SO4 is a sulfate ion. So aluminum sulfate to be here. But lead Lead is a transition metal. So because this is a transition metal, we need to know what's the charge here for lead. So usually oxygen is what? A 2 minus, right? So what will be the oxidation number here for this one? All right, so oxygen is usually what? -2. So 2 times -2 having -4. So remember here, the net charge of a compound without, that's not an ion, will be equal to 0. So which number will make -4 to get it equal to 0 here? So +4 plus 4 minus 4 is equal to 0. So the answer is this one here, right? Lead peroxide. So number 15. What's the mass of a sample of oxygen gas which has a pressure of 700 millimeters of mercury at a temperature of 25 degrees Celsius in a volume of 250 milliliters? So this one here, we're going to use ideal gas law. PV equal nRT. So the pressure here is millimeters of mercury. We need to convert it to ATM. So 740 millimeters of mercury. So each one ATM is 760 millimeters of mercury. So that we need to convert from millimeters of mercury to ATM, we're going to divide by 760. So we have here 740 divided by 760, have 0.9736 ATM. What else we need to convert in here? Temperature should be in Celsius, right? How do you convert a T to Celsius? So you take the number given in Celsius and we add up plus 273. So the answer is going to be 298 Kelvin, right? And the R is a constant. The R will be given 0.0H2O6 liters ATM per mole Kelvin, right? And the volume, look here. The volume is to be in liters, pressure should be in ATM, and temperature should be in Kelvin. I've seen all 4 units show what you should be doing conversion here. So volume was given in 250 milliliters. To convert from milliliters to liter, we just divide by 1,000. So it's going to be 0.250 liters. And then you plug it in this equation to solve for mole number, right? Here it will be mole number is equal pressure times volume divided by RT. Pressure is 0.9736 ATM. Volume is 0.250 liters divided by R. We have all this R here, 0.0206. All the units here, right? Liters, ATM, per mole Kelvin. Times the temperature in Kelvin, 298. So one thing, when we work like in division, put only is in the denominator here, the bottom, put everything between parentheses like this. Because sometimes your calculator will not make the correct calculation. So multiply this by this, divided, open parentheses in your calculator, multiply, and then close the parentheses, right? In the unit, it will be in moles. So number n is gonna be in moles. Calculate to find the moles. But your question is asked in grams, right? So after you find your mole number, how to convert from moles to grams? You multiply your moles that you calculated here by the molar mass. What's the molar mass of O2, oxygen gas, right? Will be 32. So multiply your moles by 32 grams per mole to find your grams here. Okay, so this one, the element X has three natural occurring isotopes. The masses in percent abundances of the isotope are given in the table below. The average atomic mass of the element is. So to do this average here, we're going to take the mass of each one multiplied by the abundance, right? So gonna be 220.9 times 74.22 divided by 100. All the abundance here is in percentage. So plus 220.0 times 12.78 per 100 plus the last one, 218.1 divided by times 13.0 divided by 100 here. So this is percentage, this is a percentage, and this is a percentage. This is why I'm dividing here by 100. So multiply this by this, plus multiply this by this, and then this by this to find your average here. If you wanna, maybe also put in parentheses here. Open parentheses, do the multiplication here, close the parentheses, plus the second one, so the first one, the second one, and then the third one here. Okay? All right. A compound is found to contain 63.52% of iron and 36.48% of sulfur. Find the empirical formula. So when you see percentage for empirical formula, when you see percentage, we're going to assume that the total is 100 grams. But it means where we're seeing percentage, we're going to write grams. 63.52 grams of iron. And the sulfur, you have 36.48%. That's going to be 36.48 grams. Right? Now let's find the moles. By dividing each one by the molar mass. The molar mass of iron is 55.8. Divide by 55.8 to find the moles, right here. Find the moles. And the sulfur, the same thing. Divide 36.48. The molar mass of sulfur is 32.06 grams per mole. Right? And then find the moles here. So let's calculate it here, 63.52 divided by 55.8 is equal to 1.138 moles, and then 36.48 divided by 32.06, you have is 1.1378 moles. Okay, so we're gonna divide it by the smallest. So in that case here, you can see the smallest are almost the same, so the ratio gonna be 1, 1. Divided all by the smallest. So in that case, this is the smallest, right? So if we divided this by this, we have 1. And this by this, we have 1. In that case, the answer is easy, right? And then unsaturated solution is one that unsaturated, means what? No, right? That it means it's not saturated yet. If it's not saturated yet, it is in lower concentration than its solubility, right? Then select the correct answer. Then question 19, was the half reaction for the zinc with hydrochloric acid? So let's scan here, zinc and hydrogen. So the zinc is changed to oxidation number 0, right? When we have the element in its natural form, that means without any charge, the oxidation number is 0. So here, from 0 to 2 plus, what did it happen here? Lost or gain electrons? Lost, right? If it's lost, what will have? Oxidation or reduction? So I have to remember this, right? Oxidation is loss. So we have oxidation here. And reg means reduction. Reduction is gain. Reduction is gain of electrons, while oxidation is loss of electrons. So that it means from zinc 0 to zinc 2 plus, you had oxidation. And from H plus to H0, you have that gained electrons, so you have reduction. Here. So select the answer. The answer is oxidation. Which one is showing oxidation? The one that's losing electrons. So if it's losing electrons, the electrons should be in the product side. So should be the answer A. Here, I've seen here, right? Zinc, changing from zinc to has the product show zinc 2 plus, and you have the electrons in the product side, that means it's leaving. Okay, so this one, give you the name for the following compounds. I'm gonna request to try to answer this one, right? The formula weight of the silver chromate, I believe you'll know how to answer this question, right? This one, silver times 2 plus chromium plus oxygen times 4. And this one, 22. The mass percentage of methane is. So we're going to take the mass. So carbon is 12, right? Put out the table here, you can see carbon 12. And hydrogen is 1. Carbon 12. And hydrogen, hydrogen is about 1 grams per mole. How many hydrogens we have here? 4, so hydrogen, so 1 times 4 So we have a total 4 grams per mole of hydrogen, right? And so when you have the percentage of anything, you are to take the mass of the component by the mass of the total times 100. So what's the total here? The total is 4 plus 12 is 16. In another word, just divide the hydrogen portion, that's 4, divided by 16, then times 100. All right. So octane, pretty much balance this one, right? Just make sure you have the same number of each atom in both sides, the reactant and the product, right? So if you have like 8 carbon here, you should have 8 carbon here. And if you have, so we need to balance it here. So let's try to work this one if you can do it. I'm gonna write it here, just to have one here. Okay. Okay, now let's start doing this. 8 carbon, 8 carbon. All right. Now let's try to work with 8 times 2, 16. Oh, let's use the hydrogen. 18 hydrogen, so 9 times 2, 18 hydrogen, right? Now let's check the oxygen. Here you have only 2 oxygens, right? And you have 8 times 2, 16, plus 9 times 1, 9. So in the product side, you have 25 oxygens. So here you have the odd number, but here oxygen, you have 2 oxygen. How we gonna get this? So let's take this number 20, the number of oxygen, 25, divided by 2, right? But don't want this. Don't want to have a fraction. So don't want to have 25 divided by 2, because 25 divided by 2 will be 25 times 2 divided by 2 will be 25, but we do not want a fraction. So let's take this number 2 here and multiply all the equation by 2. So 2 here, cancel out this number 2. So 16, so 8 2 times 2, 8 times 2 is going to be 16, and 9 times 2 will be 18. So the answer should be 2, 25, 16, and 18, right? All right. So this equation here, calcium carbide reacts with water to produce acetylene, as shown in the imbalanced reaction below. So we need to balance this question here. Okay, so calcium, one calcium, 2 carbons, 2 carbons, okay? And then you have 2 hydrogens, but here you have 2 hydrogen plus 2 hydrogen, so have a total of 4 hydrogen here, right? So how we're gonna work here? Try to balance this problem here. I'm gonna answer this question here in the next video.